So in our previous lesson, we talked about the scientific method. So let's look at a couple of important historical experiments that demonstrate the scientific method, and more specifically, what a controlled experiment is. Now what we're going to be looking at are a set of experiments that have to deal with the concept of spontaneous generation. Remember, spontaneous generation was the mistaken theory that living things could arise from non-living material. And this theory was well accepted within the scientific community for hundreds of years. And it took many scientists and a lot of experiments to actually finally disprove this erroneous concept. So let's look at some of the famous experiments that helped lead us toward a better understanding of what life actually is, and also show us what a controlled experiment is, a good controlled experiment. Let's first start with the Reedy experiment. The Reedy experiment was a very simple experiment. In fact, some of you probably could have even done it as a science fair project in middle school. But it was a very significant historical example of a great controlled experiment. Now the premise was very simple. Reedy challenged, if living material could come from non-living material, then if I put meat, which is of course non-living anymore, in two different containers, covered one and left one open, then material would arise from both meat containers. Now how he of course believed differently, that it was something else, perhaps flies laying their eggs in the meat, and that if the flies could not get to the meat, they could not lay their eggs, therefore the maggots could not appear. This is what the experiment looked like. So you can see he had two sets of jars, uncovered and covered. His controlled variables were the jars, the type of meat, the location, the temperature. All those things had to be controlled because remember, it was a controlled experiment. His manipulated variable or independent variable was the covering. One set of jars had the covering, one set of jars did not. And then his dependent or responding variable was the appearance of maggots, whether or not they appeared. What did he learn? He learned that maggots could only appear in the meat when the flies could actually come in contact with the meat and lay their eggs. This experiment was a significant blow to the idea of spontaneous generation. However, it would still take many more experiments before spontaneous generation as a theory was finally put on the shelf of history. Another experiment was done by John Needham. However, this experiment had some issues, and so you won't really learn too much about it in science classes because his experiment was not controlled properly. Scientists claimed he did not properly sterilize the equipment he was using, and his conclusions were erroneous. So his controlled experiment was not done properly, and so consequently we don't spend much time on him. Another great experiment that shows you an example of how a controlled experiment can be affected if all constants are not held constant or controlled properly is the Spallanzani experiment. Now he was on the right path. He had broth set up in different flasks, and he boiled them to sterilize to prepare them. That was an important controlled variable that had to be taken care of. However, there was a mistake with this experiment. You can see he left one flask open, showing that microorganisms could get in. The second flask, which he also boiled and sterilized, he then sealed. That was kind of to be similar to what the gauze effect had in the Reedy experiment. And of course, what would you expect? No microorganisms. Now, one might hypothesize this definitely proves that spontaneous generation is not possible because life could not get into the flask. However, many scientists questioned Spallanzani's work because they felt he did not properly control his variables. The manipulated variable, very easy to identify. The manipulated variable, of course, was the opening of the flask, the responding variable, the growth of the material of the microorganisms in the gravy. However, he got some of his controlled variables wrong. He sealed the flask. And by sealing the flask, not only did he keep microorganisms out, he kept oxygen out. And by keeping oxygen out, he did not control his experiment properly. And consequently, his hypothesis could not be proven properly because his conclusions were erroneous based on the work that he had done. Because in the end, you don't know if it was the flask being sealed that kept the microorganisms out or the fact that there was no oxygen, so microorganisms couldn't live. So Spallanzani's experiment, although a good premise, was not accepted by the scientific community. It would take another great scientist by the name of Louis Pasteur, whose slide I just kind of showed you a little teaser of, to actually get the experiment right. He redid that experiment, but changed it subtly. Are you ready for this incredibly dramatic change? Look at what he did. He boiled the flask the same as Spallanzani did. However, he used a different connector for his. His neck was different. His neck allowed for the passage of oxygen to pass in through the flask, but not microorganisms. Microorganisms could not make the trip all the way up and around the neck of the flask. Consequently, microorganisms didn't grow until he broke the lid off and snapped the neck. And once he did, the microorganisms were able to easily get inside, and of course they grew. Okay, as we say here, broth is boiled. The broth is free from microorganisms, even though oxygen can get in. The microorganisms cannot. Once he broke the curved neck, the microorganisms could easily get in. And then they grew. What is the manipulated variable? The shape of the neck. What is the responding variable? The growth of the broth. This was a humongously successful experiment, a great example of a controlled experiment, and led to a process that still bears his name today, which is called pasteurization. And once and for all, the question of spontaneous generation had been put to rest. This is a great place to stop for today, and in our final lesson of the unit, we'll take this a step further. Now that we've kind of defined how life can occur and what it can come from, it's time to look at the characteristics of life. So let's finish the unit by watching a video on Louis Pasteur's work.
Around 1860, French scientist Louis Pasteur conducted a famous investigation that has all the features of modern scientific method. By then, it was known that microbes are found in many places. Pasteur himself had found them on dust particles in air and in vats of soured alcohol. The problem was, no one knew for sure where these microbes came from. Many believed they were created by a special life force in the air, in a process they called spontaneous generation. Pasteur thought this was nonsense. Like some others before him, Pasteur believed that microbes could be carried by, but not created by the air. So Pasteur formulated a hypothesis, an educated guess that gives a possible answer to the problem. He hypothesized that a flask of broth would stay sterile as long as no airborne microbes could get in and use the nutrients in the broth to multiply. He then tested his hypothesis by conducting an experiment. Pasteur placed broth in special swan-necked flasks and heated them to force out all of the air. As the broth cooled, the air could get back in, but dust and microbes could not, because they became trapped in the swan-shaped neck. Pasteur observed that the broth in the flasks remained clear and therefore sterile. When he broke off the neck of the flask, allowing airborne microbes to get in, the broth became cloudy as the microbes grew within it. Pasteur concluded from these results that he should accept his hypothesis rather than rejecting or modifying it.